Let us discuss post-lab experiment 2. Post-lab experiment 2. What is the title of the experiment? Acid-base titration. So what is the acid in this experiment? Our acid is hydrochloric acid. And what is the base? What is the base we use in this experiment? NaOH. So now what is the title? Acid-base titration, determination of the concentration of acid solution. So what is the acid in your experiment? Hydrochloric acid. Objective of the experiment. Okay, what is the objective of the experiment? To determine the concentration. We just follow the title. To determine the concentration of, what is your acid in your experiment? Hydrochloric acid solution. So this is your objective of the experiment, to determine the concentration of hydrochloric acid solution. Now let us see this result. Molarity is required to run a titration. So what is the meaning of titration? Titration is a laboratory techniques to determine the concentration of unknown concentration. So here let us see what is the unknown concentration solution in this experiment. Molarity is required to run a titration between 10.00 ml of hydrochloric acid solution of unknown concentration. So in this experiment, we don't know the concentration of hydrochloric acid. So that's why we want to do titration. Okay, let us continue. We also used 0.20 molar of standard sodium hydroxide solution. 2 drops of phenolphthalein is added to indicate the end point of the titration. Okay, so here what is the function of phenolphthalein? Phenolphthalein is indicator. We use phenolphthalein as indicator. What indicator will do? Indicator will change the color when end point will reach. Okay. Now in this first paragraph, what we can understand? We can understand that we got two solutions. One is standard sodium hydroxide solution with 0.20 molar, and we got hydrochloric acid solution, but we don't know the concentration. We just know the volume. How much the volume? 10.00 ml. Let us continue. Before starting the first titration, burette reading is set to 2.500. So 2.500 is what? Initial reading of the burette. So what is the initial reading? 2.50 ml. Why got 50? Because burette should be 2 decimal point. Then Molarity start to do the titration. Once the color of the solution inside the conical flask change from colorless to pale pink. So what is the observation in this experiment? The indicator will change the color from colorless to pale pink. That persists for more than 30 seconds. Molarity immediately stopped the titration and record the reading as 12.80. So 12.80 is what? 12.80 is the final burette reading. After repeat the titration 3 times, how we know Molarity repeat the titration 3 times? Because we got set 1, set 2, set 3. That means Molarity repeat this experiment 3 times. The data obtained as below. What we want to do now? We want to calculate the concentration of HCl. Okay. So let us see this data in the table form. Gross reading. So here we got the gross reading. So what is the purpose of gross reading? Gross reading, we can estimate how much the volume of titrant used. So that is the purpose of gross reading. Okay. Let me calculate. Let me discuss here what is your titrant and what is your analyte. So before you continue, once you get this kind of question, what you have to do, you have to sketch what is going on. Okay, so we just sketch based on our information here. I got a burette. Okay, let's say I got a burette. Here is the burette. Okay, so I draw nicely a bit. You have to sketch, then only you can understand. Okay, I sketch a burette here. Below burette, we got a conical flask. Okay. So inside the conical flask, we got a solution. After that, inside the burette also, we got a solution. So this one is burette. This is our burette. And this is our conical flask. What is the solution inside the burette? NaOH. What is the molarity? 0.20 molar. So the solution inside the burette we call as titrant. What is the solution inside conical flask? HCl. We don't know how much the molarity. So the solution inside the conical flask we call as analyte. Okay, how much the solution inside the conical flask? 10.00 ml. Okay, now let us see information from the table. From the gross reading, my initial reading is 2.50. My final reading is 12.80. So how much volume of sodium hydroxide is used? 10.30. So this is the volume of the titrant used in gross reading. Okay, after that, Malati already repeat the titration for 3 times. So initial and final reading was given. Now let us calculate how much the volume of sodium hydroxide used in the set 1, set 2 and set 3. So here 10.10, here also is 10.10, here also is 10.10 ml. Now let us answer this question. How many decimal point for burette reading? So just now we already discussed the decimal point for burette reading is 2. State the initial reading for the first titration. First titration means the gross reading. So for the gross reading, what is the initial reading? 2.50. Let us see the following question. State the final reading for the first titration gross. So just now what is the final reading? 12.80. State the volume for gross reading which used to estimate the volume of titrant. So what is our titrant here? NaOH. So how much volume of NaOH used in gross reading? The final reading minus initial reading. So you will get 10.30. Let us see this question. What is the total? So the keyword here, total. Total volume of the solution inside the conical flask. So what is inside the conical flask? Our analyte HCl. for the final titration. So here is another keyword. I want to know total volume of HCl in which titration, my final titration, set number 3. So how to answer? So you have to know before you do the titration, how much the volume of the solution inside the conical flask, how much of HCl inside the conical flask before you start to do the titration. 10.00 ml of HCl. This one before titration. After titration, how much of titrant? How much of titrant already add here? Our NaOH, how much already add here? 10.10 ml. Titrant already add into the conical flask. So now, how much is the total volume inside the conical flask after the titration? So 10.00 ml add with 10.10 ml. So what is the answer? 20.10 ml. So this is the final volume after the third titration. Let us continue. Calculate the average volume of NaOH used. If we want to calculate the average, we won't take the gross reading. We just take the titration reading from set 1, set 2 and set 3. So here what is the volume of NaOH is used? 1.10, 1. Sorry, 10.10, 10.10. Okay, so if you want to calculate average, how to calculate average? Your first reading, the volume of NaOH plus with your first reading of NaOH plus with the second reading 10.10 plus with the third titration reading divide with 3. So after that you will get the answer. Average of volume of NaOH used is 10.10. Okay, the following question. Give the coefficient for the chemical equation below. So here one of our reactant is NaOH and HCl will produce NaCl and water. So now let us balance this equation. So Na will be 1 here because here got 1. So here Na will be 1. O here got 1. H here got 1. Here got 1. So 2. Okay. So I need 2H. So already 2H here. So that means here will be 1. Here will be another 1. So the coefficient for NaOH is 1 and for HCl is 1. That is the answer. State the molarity of NaOH used in this experiment. So the molarity of the titrant already given in the question. So what is the molarity? 0.20 molar. Now let us see the following question. State the formula used to calculate molarity of HCl. So what is the formula we use to calculate molarity of HCl? MaVA MBVB equal to A over B. Now let us see how to calculate the molarity of HCl. HCl. Okay, before that, you need few information. Coefficient from the balanced chemical equation, just now we already did. 1 mole of NaOH equivalent with 1 mole of HCl. So this statement is very important because we are going to use to calculate molarity of HCl. Okay, we are going to use this formula to calculate the molarity of HCl. So I want to calculate the molarity of HCl. So we just rearrange this formula here. Okay, let us rearrange the formula. I want to calculate the molarity of HCl. So when I rearrange, I will get A times M, B times V, B divide with B times V A. Okay, so now what is A, what is B, what is MB, what is VB, what is VA? Okay. A is the coefficient for HCl. A is for HCl. So what is the coefficient for HCl is 1. B, what is my B here? So my B here will be NaOH. So what is the coefficient for B? Sorry, for NaOH? 1. Okay, so I already know A and B. So now what is your molarity of NaOH? 0.20. What is the volume of NaOH we use? Average 10.10. So you already know MB and VB. Okay, now what is your VA? VA means your volume of the acid we use. The volume of the acid we use is 10.00. Now you can substitute into the formula to solve. I want to calculate the molarity of acid. So my A is 1. My molarity of NaOH is 0.20. My volume of NaOH is 10.10. Divide with my B is 1 here. My volume of the acid is 10.00. So when you calculate the molarity of the acid, you will get 0.20 molar. Let us continue our report. What is the acid solution used in this experiment? So we use HCl. What is the indicator used in this experiment? So we use phenolphthalein. Phenolphthalein. Okay, the following question. State the color change during the end point in this experiment. So what is the color change? Colorless to pale pink. Okay, the following question. State the volume of titran. What is your titran in this experiment? My titran is NaOH. How much volume of titran used after reaching end point? So the volume will be 10.10. Let us continue. State the titran in this experiment. So what is the titran? NaOH. 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 What is the analyte in this experiment? So my analyte will be HCl. The following question. What is the standard solution used in this experiment? So our standard solution here is NaOH. Okay, the last question. Does addition of distilled water affect the result of titration? So the answer is no. Just now got one question. Does addition of distilled water affect the result of titration? The answer is no. Why? Why when you do the titration, when nearly going to reach the end point, you will add distilled water. Why the distilled water never affect your result? Because water do not react with acid and base. So this is the answer. State one problem that Malati might encounter during the experiment. What is the problem may Malati faced? So difficult to get pale pink color as good endpoint. After that, state one precaution step can be taken during the experiment. So what we can do? Add titrant drop by drop. Our last question. State the conclusion for this experiment. Molarity of HCl is 0.20 molar.